Our solutions to perfect problem 1 for Math 243. Give it a bunch of data. It's the number of home runs hit by American League right fielders in 2011. I think these are right fielders with at least 200 at-bats, in case you're curious. And we're asked to do a bunch of stuff. We're asked to calculate our 3 measures of central tendency and our 3 measures of dispersion without using statistical functions on our calculator. If you want to add some analysis and commentary, feel free. All right, so let's first figure out our mean, which is equal to x bar. And the way you get x bar is you add up all these numbers. I think if you add up all these home runs, what you'll end up with is 256. And you divide by how many you have. In this case, we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. By the way, Meglio only hit 5 home runs, not 8 last year, but I changed this point right here to make the data work out a little bit nicer. So anyways, the mean is 256, what we get when we add up all these numbers, divided by how many numbers we have, which is 16. 256 over 16 is exactly 16. The median, the way you figure that out is it's the n plus 1 over 2 largest observation. We already figured out that n was 16 because we have 16 observations. So it's the 17 over 2, which is the 8.5 largest observation. How can you have an 8.5 largest observation? Well, I guess you can't, but you could take the average of the 8th and the 9th. The 8th hit 13, the 9th hit 15. 13 plus 15 divided by 2 is 28 divided by 2, which is 14. So our median is 14. Mode is saying which numbers occur most frequently. Say we got 2 23s, 2 20s, and 2 8s, and 2 5s. So our mode is actually 4 different numbers. It's 5, 8, 20, and 23, I think were the ones I said. You don't do anything with these. You don't average them or anything. You just leave it as it is. The mode is that. The range, so this is our first measure of dispersion. You use a capital R for this, is the largest observation minus the smallest observation. So 43 minus 4, which in this case is 39. Variance, I think this is the first difficult one to calculate. The way you calculate that is, I'll show it up here. First, you want a list that shows all your data. You usually call these guys x sub I. And then right next to it, you write x bar, which your average is. In this case, it's 16. So we just got a column of 16s going down here. Maybe I didn't have to write it this many times. I could have put dot, dot, dot or something. But I did. The next column is x sub I minus x bar. In other words, how far above or below the mean is each one of these observations. Okay, 43 minus 16 is what, 27? 29 minus 16 is 13. 23 minus 16 is 7. 20 minus 16 is 4. 19. 15 minus 16, negative 1. 13 minus 16, negative 3. 8 gives me negative 8. 5 gives me negative 11. And 4 gives me negative 12. So now I have a whole column that tells me how far away each of my observations is from the mean. The next column I want is x sub I minus x bar squared. In other words, I want this column, but I want all of the numbers squared. The only one that's, let's see, 27 squared is 729. 13 squared is 169. 7 squared is 49. 4 squared is 16. 3 squared is 9. Negative 1 squared is positive 1. 3 squared is 9. 5 is 25. 36, 64. Negative 11 squared is 121. And negative 12 squared is 144. So what we want to do is sum up this entire column right here. That you will get 1,622. And so using this, let's see, our variance is equal to the sum of this xi minus x bar squared column divided by n minus 1. Well, the sum of this column is this 1622. So my variance is 1622 divided by 16 minus 1 is 15. And if you calculate that out, you get 108 and some change, 0.13 repeating. So 0.13 repeating. So this number right here is our variance. And once you know the variance, you can figure out the standard deviation, because the standard deviation is just the square root of the variance. So if I take the square root of this number right here, the square root of 108.13 is approximately, what, 10 points, maybe I'll call it 10.4, 10.3987, depending on how many decimal places you want to carry. But you get something like that. And that is our last measure of dispersion. So we got 3 measures of central tendency and 3 measures of dispersion. You could do some commentary. You could, I don't know, make a stem and leaf plot or a histogram, or there's a few things you could do with this. Commentary that you might add is, well, there's lots of things you could do, but the thing that would jump out to me is I'd say that the mean is bigger than the median. So maybe this optional commentary right here would be because the mean is greater than the median, the data may be right skewed. And there's other things you can write too, but I think that's the main point that we learned in this section. So I will leave it at that and call that the end of the perfect problem.